The speed of objects in space can appear faster compared to the speed of objects on Earth because of a few different factors. 1. Lack of friction. In space, there is no atmosphere or air resistance, which means that there is no friction to slow down objects in motion. On Earth, the resistance of air molecules creates drag, which causes moving objects to lose speed over time. However, in space, this is not a factor, which allows objects to maintain their velocity without any external forces acting against them. This lack of friction is particularly important for space travel because it allows spacecraft to move at incredibly high speeds without expending a lot of energy. Once a spacecraft has been launched into space, it can continue moving at a constant speed without the need for additional propulsion or fuel. This makes it much easier and more efficient to travel long distances in space. Additionally, the lack of friction in space means that objects can move in a straight line without being pulled off course by external forces. This is particularly important for spacecraft that need to maintain a precise trajectory, such as those traveling to other planets or moons. Without the resistance of air or other forces, spacecraft can stay on course more easily and with greater accuracy. Overall, the lack of friction in space is a crucial factor in allowing objects to travel faster and more efficiently than they can on Earth. 2. Lower gravitational forces. The gravitational forces in space are significantly weaker compared to those on Earth. Because gravity is dependent on the mass of the objects involved and the distance between them. As objects are usually farther apart in space, the gravitational forces acting on them are significantly reduced. These weaker gravitational forces are particularly important in space travel as they enable easier and more efficient spacecraft launch into orbit and maintain its motion. Launching spacecraft on Earth requires tremendous energy to overcome the force of gravity pulling it towards the ground. But in space, the weaker gravitational forces make it easier to launch a spacecraft into orbit and maintain its movement. Moreover, objects in space can travel at higher speeds without being deviated from their trajectory. On Earth, the gravitational forces cause objects in motion to follow a curved path. However, in space, the weaker gravitational forces mean that objects can travel straight at higher speeds without being affected by the gravity-induced curved trajectory. Overall, the lower gravitational forces in space allow for efficient and easy spacecraft launch and travel, while also enabling high-speed motion without being affected by gravity-induced trajectory curvature. 3. Orbital mechanics. Orbital mechanics is the study of how objects move in space under the influence of gravity. It involves using the gravitational forces of celestial bodies, such as planets and moons, to achieve and maintain a spacecraft's speed and trajectory. One of the key concepts of orbital mechanics is the use of a gravitational slingshot or gravity assist. This involves using the gravitational pull of a planet or moon to increase a spacecraft's speed and change its trajectory. As a spacecraft approaches a planet or moon, the object's gravity pulls the spacecraft towards it, accelerating it as it passes by. The spacecraft can then use this increased speed to continue on its mission, conserve fuel, and even change its direction. Another important concept of orbital mechanics is the use of transfer orbits. This involves using the gravitational pull of a celestial body to transfer a spacecraft from one orbit to another. For example, if a spacecraft is in orbit around the Earth and needs to travel to Mars, it can use a transfer orbit that takes it close to the orbit of Mars. The gravitational pull of Mars then captures the spacecraft, and it can enter into orbit around the planet. Overall, orbital mechanics plays a crucial role in space travel and exploration. By using the gravitational forces of celestial bodies, spacecraft can achieve and maintain high speeds and change their trajectories without expending a lot of energy. This makes it possible to travel to other planets and moons in our solar system and explore the universe beyond. 4. Time dilation. Time dilation is a phenomenon that occurs in space as a result of Einstein's theory of relativity. According to this theory, time is not constant but is relative to the observer's speed and the gravitational field they are in. The theory of time dilation states that time passes more slowly for objects that are moving at high speeds or in strong gravitational fields. This means that the faster an object travels or the closer it is to a massive object, the slower time appears to pass for it. For example, if an astronaut were to travel at a high speed relative to Earth, time would appear to pass more slowly for them than it does for people on Earth. This means that the astronaut would experience time differently than people on Earth, and they would age slower. Time dilation is particularly important for space travel because it can have a significant impact on the accuracy of GPS systems and other technologies that rely on precise timing. Because time passes more slowly in strong gravitational fields, satellites in orbit around the Earth experience time differently than people on the surface of the Earth. This means that the clocks on these satellites need to be adjusted to account for the time dilation effect to ensure accurate timing. Overall, time dilation is a fascinating and important phenomenon in space travel and exploration. It helps us understand how time and space are interconnected and has practical applications for technologies like GPS.